Hey guys, Bukoid here. Going to give you a video. Hey, we're having some sort of a solar wind event, guys. This is something that we've been expecting. This isn't something that was out of the ordinary. We're getting coronal holes. We had some coronal holes that were earth facing that have now rotated off earth facing, but there's some right behind it getting ready to come through. So we should be watching out for earthquakes. The uptick in intensity, frequency, all those kinds of things, all those above, plus other stuff that could happen. We could get satellite disruptions. On the good note, you can, if we get a big enough event, there's a lot of photographers out there that try to catch the astrophotographers, catch the aurora borealis, the northern lights. When we have these events, sometimes that stuff will creep down into lower latitudes, which means it gets down into the wider part of Earth, lower towards the equator. So, the bigger the event, the better it is for them because it does show more. So that's a good thing about this stuff. But, we really have to pay attention because we know that this does increase earthquake risks and all those kinds of things. Obviously, first guy to go to for earthquake stuff, Dutch Sense, without question. And whatever knowledge he uses for what he does, I don't even question it, okay? Seriously, guys, because he predicts it and it happens. So take that for whatever it's worth. Now, I'm going to show you these waves that come through here. And what concerns me, guys, is the frequency of back-to-back here, okay? So there was kind of a little wave there. All right, this is also a good way to show you how the energy kind of goes behind us. Now you see that in the back. Okay, I'm going to start it right there. What I want you guys to look at is right here. We had some energy hit us in the front, so it has to release somewhere, right? Well, it's releasing in all directions to begin with, okay? But we see it more on the back because we're not seeing... The sun is always pushing this way against us. So that's why a lot of the energy looks as if it just comes off the back. In reality, it's actually coming off the front and then getting kind of pushed back that way. It's coming off all directions is what I'm saying. But we just see it more in the back. But watch back here. This is a really good capture here to show you this. Okay? So here, you watch it separate. Right there. Then you can see it move on out. Watch. See that? Now, notice what's happening around the whole Earth when that happens. We're expanding out in all directions. Watch. See that? Okay, and I know it's very subtle. Okay? And that's why most people don't see that. Okay? Only somebody that's been watching these things for a long time would actually kind of pick up on that. And that's, and that's why I'm here, I guess. I don't know. Hopefully you guys can understand what I'm saying to you here. But you can see how that energy just gets absorbed and then we release it, right? And it goes right on out the back. See that? Okay? Now, what I'm talking about here is, watch this. Okay, that was some energy that hit us. See how we kind of tilted a little bit? That's not out of the ordinary. That happens a lot. The Earth itself didn't tilt. It's just the magnetics, okay? I don't want people freaking out over that. So, did you see that little quick, a bit? Okay, this is how fast it happens, guys. Watch. I'm talking, it's there, and 4 minutes later, it's there. Okay? That's how fast it happens. So, that was the first hit, okay, which is whatever, okay? Another one, see that? Now, then this is where we have to stop and be like, what? Okay, because if it gets inside the satellite line, we can be seeing some pretty good disturbances, And like I said, why is it important about the waves right behind each other? Well, because our magnetic shield doesn't have enough time to rebound back out to protect us fully. So the waves that are coming in behind this, if they're close enough, more energy gets through. You see how it's doing this? Okay, and it's wave after wave after wave. Then it seemed to quiet down, and then at the end of this, as I'm doing this, it seems like we might be getting some more energy here getting ready to hit us. Okay, and this energy isn't going to stop. It's going to continue. Okay. Now, I don't know if the density itself is going to continue, but this is a very high dense, and I'll show you what I mean here in a minute after I show you these other models. I'll show you guys how to look at the proton density too. Okay, so now you see this, okay? Boom. Okay, that was the first initial wave. Now, what I want you guys to pay attention on this model, this does actually show the solar wind speed. It never gets up over like 700. Now, in order to have these kind of big disruptions, typically that solar wind speed would be up over 1,000. Okay, but it's not. So that tells us that it's more dense material. And there's places to look to find out that. All right, now as we go through here, watch. Boom. Okay, we're starting to get hit. And then there's that first initial wave. Watch. Boom. See that? Now watch what happens after this. Boom. And then boom. There's the first really big one. Now, if you're watching the solar wind speed up there, it never got up like over 600, 700, right? Why is it acting like that? It's because the particles are more dense. Okay? Ooh, I don't like that number. Did you see that number? Ooh. Look at that number, guys. Oh, wow. Okay. Whatever. We'll just keep moving on that one. Okay, now, see, look. Here's the first wave. Look how close the second wave's right behind us. See where our shield's at? It's having a hard time getting back out there to protect us. It's closer to us because of this. Okay, and then wave after wave come in here for a minute. And they're real close to each other. And it calms back down a little bit, and then you see this, right? Okay, so anyway, I wanted to show you that. Now, is that the other one? Nope. Let's see here. I want to show you the spaghetti string model too, which is what I call it. This is just the lines of magnetism when I show you guys. This actually kind of does show the waves pretty well of energy coming in. Boom. Okay, here we go. Now the blue lines, guys, are our connection to the sun and other celestial objects. Black lines are the pole lines. They come off the north and south pole. And the red ones are closed field lines. Okay. See, look at this. I mean, is that not just completely odd? I don't want to call it odd, because I'm sure we've seen this before. But when we see those waves that close to each other, see that? Just boom, 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 boom. It'd be like a boxer just getting hit with a barrage of punches all at one time, instead of one big knockout blow. Okay, that's kind of what it's like. So I wanted to show you that one. Now I'm going to pause for a second. Okay, guys, got you back here. This is the Australian model. Okay, this is the Magnetopause Australian model. This actually gives us a capture every minute. Okay, now this also does something good for us too. It tells us the proton density on each minute. Okay, where do we look at for that? Right there. Okay, where should that proton density be? Typically it runs right around 3, 4, 5. A higher dense day would be more close to 10. Okay, and that's even kind of high. But watch what happens. Watch that proton density as I go through. This is at 1600 UTC. Look at that. Now, I think even like a 5-year-old will understand that's a big difference. Okay, 4.7 proton density. That's centimeter to the third power. Okay, guys. They all use the same unit of measurement. That's what they use for the density here. Okay, all the models do. All the ones I show you guys anyway. So, that's 1 minute later. Okay, it goes from 1603 UTC to 1604 UTC, and look at all that density happened. That's like, man, that's a lot of density. Okay, I'm just saying that's very, very heavy density material. Okay, now it wasn't just the only wave. And let me show you, because I'm just toggling this through. As you can see, 37 to 63. Here's that other wave coming through. Now look at that one, guys. This is the one that kind of had my jaw dropping. All right, that's 160. We'll just call it 160. 159.7. Now, as we look at this, we can see the satellite line here too, right? So we can see our shields are getting backed up. And it doesn't have enough time to recuperate to protect us fully between the next wave coming. Okay? Because as I'm going to show you right here, you see how quick it started going right back towards us? Now, if we had high density material, 169, right after each other, you can bet we would be seeing some disruptions. There's a 72. Okay, so I mean, and what I'm gonna do is I'm just gonna push play. We can watch it. Now you just see that. I mean, it really just woof. I mean, it goes. So let's back that up a little bit. I wanna try something here. Okay, let's go forward. We'll see what that one was. And whenever you see it jump like that, that's when I usually stop and like do it real slow. Like right here. That goes to 70. Oh wow, look at that one, guys. I didn't even see that one. 184. Whoa! Wow. Somebody's been eating some McDonald's. Got dents. Wow. Looky there. Man. Okay. Whatever. Anyway, that's some highly dense material, guys. Now, what I want to show you guys is this model here. This is space weather, okay? This is the NOAA space weather site. And I'm going to take you to the ACE. But as you can see, it's saying that the solar wind speed is 317, okay? Which isn't out of the ordinary. Geomagnetic storm levels, normal, not even active, okay? Okay, this is the ACE. All right, remember I explained to you the popcorn before? Why it looks like that? Each one, like when you see a solid line like the speed here, the yellow line, that means that the data points that it's showing you are very similar to one another. That's why it looks like it's a solid line. It's really not a solid line, okay? What it is, see these dots? Each time it gets a reading, it puts a dot on this graph. It's just when those dots are right next to each other, it looks like a solid line. So when we're seeing waves of stuff hit us, it looks like popcorn because it's fluctuating, okay? You've seen a little fluctuation there, okay? This is just the speed. But what I'm going to talk about is this. See this? Okay, as you can see, that ain't no solid line. Okay, when I've talked about this popcorn looking stuff, anytime you see this on this graph, you should really stop and look. Now, they do this on purpose on this part of this graph, and I'm going to show you what I'm talking about. See how we go from 1 to 10, all right? No harm, no foul. Yeah, our density should be 5. We can all agree to that, right? So when we come over here, if we're just looking at this part of it, that's 1 to 10, right? We would assume that this is 10 to 20. So that would, in our minds, we're looking at 25, 26, right? Right there. Well, guess what? Look what they did over here. This graph goes from 1 to 10, and then it goes from 10 to 100. So in other words, there's only 10 units from here to here. But from here to here, there's 90 units. In other words, it doesn't look as strong as what it actually is, because that's just what they're doing there. Now, are they doing it just so they can show us something without having some big huge graph here? Because it would have to be very tall, and that might be part of it. Or are they just trying to downplay what's actually happening? I don't know. I kind of feel both is going on there, but that's just me. Now, this is the Enlil. This is the other model, okay? This one here predicts and shows you historically what's happened. Okay, I'm just going to do this part like this. Okay, now what we're looking at, guys, is if we look at, right now it's like the 25th, 26th, so we're looking right here. Now, it's not predicting the wind speed. Actually, it's predicting the wind speed to go down the next 5 days ahead of us. Why? Why am I saying why? Well, look at the density. You're predicting it to slowly go up a little bit, but not drastically. No freaking 180, 190, okay? So why is this model not showing any kind of a velocity increase when we know that there's there's coronal holes? Okay, I'm gonna take you guys over to SDO. All right, and I take you guys here a lot. All you guys got to do here, guys, is I leave links to all this stuff usually. If you guys want to know how to get there, or you can go to the planetxnews.org website and go down about halfway, and there's a bunch of links to all of this stuff that I look at. So anyway, you enter the start date and time that you want to see, and then the end date, which we'll just go here to the most current, and then you pick your angstrom. Okay, basically what color you want to look at. If you want to drop it down into basic waves, it looks at different wavelengths of light. Okay, and we see different things in different wavelengths. Okay, we could start talking about different materials that was trying to look at, like helium and all those kinds of things. But I'm not going to go into that. That's very, very time consuming trying to explain. So we're going to look at the 193. Okay, this is typically the one I go to show you guys coronal holes. All right, now if you look at the date, okay, obviously this is a coronal hole, and you have another one kind of rotating in, right? Well, what we're concerned about is the Earth strike zone. Okay, that's what they call this. Now, this is the equator of the sun, right? The Earth strike zone would be right here, just south of the equator. Look what happens right there. You see that coronal hole? It rotated right through it. Now, it's going to take it a few days for that gets here. Now, when did that show up? When did it start hitting us? Right about halfway through the day on the 23rd. Okay, all the way through the day on the 24th. And then it exited right about the 25th. Now, we still have to look at this one because this one's coming. All right? And actually, it looks like it might even be opening up a little bit more on the south part of it. So, depending on the speed that material came out of that thing is when we're going to be seeing the biggest impacts. Now, it looks as though we're already seeing some impacts from it, guys. Okay? There might have even been some smaller holes out in front of it. It kind of looks like it might have been one right there. Now, it might be where this high dense wave's coming from. I don't know. We can also talk about cosmic rays a little bit. Cosmic rays, we are definitely seeing an increase in those. That's energy coming from outside, basically outside of our solar system. It's coming in. Just like the Earth has a magnetic shield, well, our solar system does too, and it's generated by the sun. Okay, it shields the whole solar system pretty much. So when the sun's in a weakened state, it lets the more stuff in. That's why you see an uptick in cosmic rays during a solar minimum, which is what we're in. Now, I don't think that this wave that we're seeing right now is actually cosmic rays. It could be part of it, but I don't think so. I think it's more so these coronal holes, okay, this time. Again, the detectors I just showed you guys can only detect, charged particles, how fast they're moving, how dense they are, that kind of thing. They cannot tell you the source of it, okay? They just can't. It assumes that it's solar wind. Well, sometimes it's not. And, something else, we've only been studying solar wind for a little over 40 years. That's only been a thing for that long. So new stuff's going to continue to come up. And that's why we continue to try to do the best we can with this. But, with that being said, be on the lookout, guys, for uptick in earthquakes and all those kinds of things. Again, this one has already rotated past the Earth strike zone. This one's right behind it. That's why it's puzzling to me that Enlil model is not showing an increase in anything at all. Okay, now something else I'm going to show you here real quick. I'm going to take you over here to this one boots up really quick. This is just the one I show you guys sometimes at the end of my videos. It shows you electronic flux. Sometimes we'll see some anomalies there. We'll see some what we call cosmic ray anomalies. Sometimes in some of this stuff. Sorry about that, guys. Stupid ad. Anyway, we'll see it'll look like a line. And just kind of one line will shoot out. And typically that's a cosmic ray anomaly. All right. But not always. But most of the time, yes. Because you can't track it back to the sun. If you can't track something back to the sun, it has to come from somewhere, right? But I wanted to show you guys that. Now I want to show you the KP model here, okay? Now it's only getting, it's at a 2, but it went from 0 to 2 right away. So what that tells us is it wasn't like a slow increase. It was a boop, jump straight up to 2. All right, so that's probably seen those that dense material hit us. And that's why that went up a little bit. This is no way any kind of huge event, okay, guys? But this increase in the solar wind and stuff has really got me concerned about earthquakes. Again, keep an eye on Dutch. Scott does some great predicting there too. There's others out there. You know, like I said before, Dutch is the man to go to, in my opinion, for earthquake stuff. Whatever data he uses to try to predict, whatever method he uses, you can't deny the fact that he's able to predict things better than our stinking government can. Okay? So when that happens, it is what it is, man. So anyway, guys, I am going to end it there. Hope you guys have a blessed week. I've been trying to slow down a little bit, guys. I'm been really tired. So anyway, God bless. Yeshua saves, and you can drink this Kool-Aid.
I don't feel the way I used to. The sky is gray, much more than it is blue. But I know one day I'll get through, and I'll take my place again if I would try. If I would try. Oh, there is no one for me to blame, 'cause I